In this video, I will discuss some capacitance problems from previous question papers of IIT JEE. This is the first question, multiple correct type question. In the circuit shown in the figure, there are two parallel plate capacitors, each of capacitance C. The switch S1 is pressed first to fully charge the capacitor C1 and then released. Switch S2 is then pressed to charge the capacitor C2. After some time, S2 is released and then S3 is pressed. After some time, option A, the charge on the upper plate of C1 is 2CV0. B, charge on upper plate of C1 is CV0. Option C, charge on upper plate of C2 is 0. Option D, charge on upper plate of C2 is minus CV0. You can pause the video and attempt this question. Here is the solution. So when switch S1 is closed, S2 and S3 are open. So only the left cell 2V0 and the capacitor C1 will come into play. When switch S1 is closed, only these two will come into the circuit. And after some time, this cell of 2V0 will charge this capacitor C1 fully, and the voltage drop across this capacitance will be 2V0. So the charge on the upper plate will be 2CV0, because charge is capacitance is the voltage drop will be 2V0, and the upper plate will be positive because it's connected to the positive polarity of the cell. And after some time, the switch S2 is closed and S1 is open, and when S2 is closed, the two capacitors will come into the circuit, and the two capacitors are identical, they have the same capacitance value. So the charge of 2CV0 will get divided between these two equally. So after some time, the charge on the upper plate of capacitor C1 will be CV0, and also charge on the upper plate of capacitor C2 will be CV0, and at the lower plate will be minus CV0 for both of them. And after some time, S3 is closed, S2 is open, so only the right cell and C2 will come into the circuit. And after some time, this cell of V0 will charge this upper plate to a potential of minus V0 because it's connected with the negative terminal, and the charge will be C into V0. Negative charge will be in the upper plate, and bottom plate will have plus CV0. So the charge on the upper plate of C1 will be CV0, and charge on the upper plate of C2 will be minus CV0. So the correct options are option B and D. This is the next question. In the circuit shown in the figure, the battery is an ideal one with EMF E. The capacitor is initially uncharged. The switch S is closed at time t equal to 0. Find the charge Q on the capacitor at time t. And second part of the question is find the current in AB at time t. What is the limiting value as time t tends to infinity? You can pause and attempt this question. Here is the solution. When the switch S is closed, the circuit will look like this. There are two loops in this circuit, so let the loop currents be I1 and I2. So the current flowing this resistance will be I1, in this resistance and capacitor will be I2, and the current flowing in this AB branch will be I1 minus I2 from top to bottom. So we can write KVL in equations loops 1 and 2. So writing KVL in loop 1, we get V equal to R into the current in this branch, that is I1 minus I2, plus I1 into R. So this we can simplify as 2I1R minus I2R. And writing KVL in loop 2, we get this R into I2 plus this R into I2 minus I1. The loop direction is this way, so the current flowing in this direction from B to A is I2 minus I1. So the drop across this resistance will be R into I2 minus I1. So combining these two drops, we get R into 2I2 minus I1 plus the voltage drop across capacitance is VC, that's equal to 0. So we have two equations. We are interested in what is happening in the capacitance, so we can eliminate current I1. So here it is minus I1, here it is 2I1. So if we multiply this by 2, the second equation, and add the first, we can get rid of I1. So this gives V equal to 3I2R plus 2VC, and I2 is the current in the capacitor, that is dq by dt, and Q is C into V for a capacitor. Here it is C into Vc. So I2 is C into dVc by dt. So this is a first order differential equation, and the variables are Vc and t. So this can be rewritten like this: time on one side and Vc on the other side. So this we can integrate from initial time t equal to 0 to some time t equal to t. Initially Vc is 0, and at time t let the voltage be Vc. So the left hand side will give t by 3RC. The right hand side is ln of V minus 2 Vc divided by the derivative of this one, that is minus 2. So putting the limits we get this one. So now we can get e raised to the power this equal to this quantity. So from this we can simplify as 2Vc by V equal to 1 minus e raised to the power 2 by 3 Rc into t. So from this get Vc as this expression, V by 2 into 1 minus e raised to the power minus 2 by 3 Rc into t. And charge in the capacitor is C into the voltage drop across it, that is C into Vc. So from this we get the expression for charge as a function of time as Cv by 2 into 1 minus this quantity. So that is the first part of the question. We have to find the charge Q as a function of time. Next we have to find the current in AB. So current from A to B is I1 minus I2. IAB is I1 minus I2. And I1 we can get from this equation as V by R plus I2 by 2. So VR plus I2 by 2. And I2 is the current that's flowing the capacitor, that is dq by dt. An expression for Q we have here. So from this we get dq by dt as this one. This is straightforward differentiation. So simplifying we get the expression for IAB as this one, V by 2R minus V by 6R into e raised to the power minus 2 by 3 Rc into t. So this is the expression for current as a function of time, and as the limiting value of this current as t tends to infinity will be this first term. As t tends to infinity, the exponential term will die down to 0. So this is the answer to this question. This is the next question. At t equal to 0, the switch S is closed. The charge in the capacitor is varying with time as Q equal to Q0 into 1 minus e raised to the power minus alpha t. Obtain the value of Q0 and alpha in the given circuit parameters. You can pause and attempt this question. So when the switch S is closed, the circuit will look like this. Let the branch currents be I2 in this resistance R2 and IC in the capacitor. So the current in R1 will be I2 plus IC, that is by applying KCL at this node. Now there are two loops here, 1 and 2. We can apply KVL in these two loops. So applying KVL in the first loop we get V equal to drop in R1, that is I2 plus IC into R1, plus drop in the capacitor, that is Vc. This is the first KVL equation, and the KVL equation in the loop 2 will be Vc equal to I2 into R2. The drop in the capacitor should be same as the drop in the resistance R2. So we can eliminate I2 from these two equations. From the second equation we get I2 as Vc by R2. Using that in the first one we get V equal to Vc by R2 plus IC into R1 plus Vc. So we can combine Vc terms, and Vc is Q by C, because for a capacitor Q equal to C into V. So Vc is written as Q by C. Now this is the first order differential equation, and the variables are Q and T. So this we can rewrite as this one: V by R1 equal to 1 by R1 plus 1 by R2 into Q by C plus dq by dt. So we can separate the variables now, T on one side and Q on the right side. So this becomes dt equal to dq divided by this expression, and this bracket is this one, 1 by R1 plus 1 by R2. So now integrating both the sides with time from time t equal to 0 to t equal to t. At time t equal to 0 the capacitor is uncharged, so Q is 0, and at time t let the charge be Q. So the integral of this will become ln of this one. So this we can simplify as, so we can get e raised to the power minus something into t equal to this one. So we get the expression for Q as 1 minus e raised to the power 1 by R1 plus 1 by R2 into 1 by C into T divided by 1 by R1 plus 1 by R2 into R1 into C into V. This is straightforward manipulation. And further simplifying, we get the expression for C as this one, CV into R2 divided by R1 plus R2 into 1 minus e raised by this expression. So the question, this is Q has been given as Q0 into 1 minus e raised by minus alpha t, and we have to find Q0 and alpha. So comparing this, we get Q0 as this one, CV R2 divided by R1 plus R2, and alpha is this coefficient, that's R1 plus R2 divided by R1 R2 into C. This bracket is R1 1 by R1 plus 1 by R2. This is the answer to this question. This is the next question. At time t equal to 0, a battery of 10 volts is connected across points A and B in the given circuit. If capacitors have no charge initially, at what time in seconds does the voltage across them become 4 volts? Take ln phi as 1.6, ln 3 1.1. You can pause and attempt this question. Here is the solution. We have to find the voltage drop across this capacitor, that is same as the voltage drop between this point, say P, and B. So we have to find the voltage drop across these points P and B as a function of time. So we can combine these two capacitors as a single capacitor, and let's combine these two resistance, because we are just interested in the potential drop from this point P to B. So this circuit will get simplified as 2 mega ohm will combine as 1 mega ohm, and the capacitors in parallel will add C1 plus C2. So it's 4 microfarad. This is a standard RC circuit, and the expression for current in RC circuit is I equal to I naught into e raised to the power minus t by 4. Here at time t equal to 0, the cell is being connected to this circuit, and I naught is a current flowing at the time in which the cell is connected to the circuit. When the cell is connected to the circuit, this capacitor will act as a short circuit, so the current I naught will be 10 divided by this resistance, so it will be 10 microamperes, and voltage drop across PB as a function of time will be total voltage of 10 minus the voltage drop across the resistance. Voltage drop across the resistance is current into the resistance value, so current is 10 microamps into e raised to the power minus t by 4 into 1 mega ohm. So mega will cancel with this micro, so it will become 10 into e raised to the power minus t by 4. So VPP, we have to find the time instant in which the VPP value is 4. So putting VPP equal to 4, we get 10 e raised to the minus t by 4 equal to 6. So you have to find the time which satisfies this equation. So this can be rewritten like this, taking log on both the sides, and 6 by 10 is 3 by 5, so it will become ln 3 minus ln 5. These values are given in the question. So using that, we get the value of time t as 2 seconds. So time t equal to 2 seconds, the voltage drop from P to B, that is same as the voltage across the capacitor, will be 4 volts. So this is the answer to this question.